Okay, let's get started. You can see my slides, Peter?
Yep.
Okay. All right. Welcome everyone to November's DataWorks Maryland meetup. Very excited to have Peter from MITRE discussing the Defend project. Um, very interesting. They have a lot of resources on the website if you want to follow along as Peter does the presentation. I'm sure he's going to go over all the details. It is related to the MITRE attack effort, if you guys have seen that. So before we get started, I'd like to do a brief introduction, introduce some of our sponsors, and then we'll hand it over. So Variant Technologies is a defense contracting company in the Maryland area that's been supporting the meetup for years. They've always been, supportive and are a great company to work for. I always try to highlight our sponsors and our partners because those are the ones that help make the events happen. ClearEdge is another company in the Maryland defense, industry, doing data science and analytic development and software engineering. If you're interested in learning more, you can reach out to them or myself. And then Areas Ventures is my company. If you're ever interested in learning more, just reach out to me and we can have a conversation. And then upcoming December, we originally had something planned. We were going to do a panel on basically artificial intelligence for disabilities. And we are going to do that, and it's probably going to happen in January or February, or maybe in spring. And it's a really interesting talk, and it's going to be focused on basically how AI can be used to assist folks like blind people making a smart cane, things like that. In January, we will have a talk on NLP. We're in the process of finalizing that. And then we have some interesting talks scheduled for 22, everything from robotics to, like I said, the disability. And then we are working on our conference. And this is actually coming along pretty well now. We're trying to finalize the venue. It's either going to be at APL or UMBC. And we've identified a couple speakers that I think are going to be kind of interesting, everything from visualization to analytics to data science. So if you're interested in learning more, please check out the website or just reach out to me. And then Peter is enlisted in the United States Air Force, where he served in Operation Iraqi Freedom, and earned a BS in Computer Information Technology from University of Maryland Global Campus. He was the principal investigator at Northrop Grumman and was the founding CTO at Blue Vector. And he holds 2 patents in applying machine learning technology to malware detection. He joined MITRE in 2017, and he is the lead for the MITRE DEFEND, a knowledge graph of cybersecurity countermeasures. And I had joked about this on LinkedIn, but he literally has written the paper. It is available. I think I put it in the resources. But if you're interested, you can find that information. And with that, the last thing I'm going to say is, like, again, if you have any questions, I'm watching YouTube and Zoom. Please post your questions. I will gather them and I'll ask Peter. And please, ask away. And with that, Peter, I'm going to give you the screen, and you can take it over.
All right, great. Let me share here. All right. Let me know if that's coming through.
Yes.
We're good.
Yep.
All right, great. Great. So thank you for having me tonight. It's great to get to speak to this group. Today I'm going to give you an overview of the DEFEND project. DEFEND is a project we've been working on at MITRE for the last 3 years. And we finally released it to the public in June in order to get feedback and help the project grow. The work was funded by the NSA, and at MITRE, we're looking to leverage this work across a variety of sponsors. And then additionally, of course, working in the public interest, we wanted to benefit the commercial community as well. So today I'm going to kind of give you an overview of sort of the motivation behind the project, the results, sort of the what we built, get into a little bit on how we built it. I'll do a little demo of the technology, and then walk through some simple use cases, and then leave you with some closing thoughts. And then, we'll take any questions that you might have. Feel free to ask away. So I'll just dive in here. So the motivation for the project. So to start explaining D3FEND, I kind of have to explain another MITRE project, ATT&CK. Some of you may be familiar with ATT&CK. And basically, it is a public knowledge base of all the sort of specific technical behaviors that cyber adversaries exhibit. And it's organized and arranged in a nice way that lets you understand the tactics and techniques that adversaries use to break into computer networks. And that had been sort of broadly adopted in the industry and across our sponsor spaces. So this sort of natural question, arose, which is, okay, now that we've succinctly described adversary behavior, is there a succinct sort of summarization of what do you do in response to the adversary behavior, sort of a defensive model, if you will. So that was the basic pitch to do the research, and then we basically chewed on that for quite some time. But admittedly, it was a very small team, so it's early stage project, and I'll get into the details there. But we set about building this because from our perspective, this entire space, we sort of categorize it as countermeasures, cybersecurity countermeasures, is incredibly complex domain. If you think about it in two large buckets, one is sort of technical policies, all the things that we do to configure our systems to make them harder to attack. Sometimes this is the compliance area of cybersecurity. It's sort of thousands of discrete things, or even more, that you do to make your system more expensive to attack, basically, right? Then the other major bucket of these cybersecurity countermeasures, vendor technologies. And if you look at this eye chart, sort of down here, you can see thousands of vendor logos, right? So think about the fact that there are thousands of cybersecurity vendors, and a lot of times we're building technologies that, get bolted onto enterprises sort of after the fact, right? So, you can imagine a security architect or a system security engineer for a company or a government organization trying to manage all this complexity. Think about the fact that there's thousands of vendors. Some of these vendors have multiple products, and some of those products perform multiple discrete functions. So, you're very quickly into, a high dimensional space, trying to think about and reason about what these what functions are being performed here. So we wanted to see if we could come up with a model to summarize all of this and help people make better decisions about their security architectures, and be able to sort of build better systems in the earlier stages of systems development. So we set about building this, and it took about 3 years to get to where we are today. But the idea was that, if you had an articulate model, it would have a variety of use cases. And what that really means is you're speaking to multiple audiences of people from different backgrounds, and each of them uses language in this space slightly differently. So for us, whether or not the model was effective or useful is a matter of, do people adopt the language? Do they agree that it's articulate enough? And that's what I call trying to sort of get this sort of semantic sweet spot of abstraction. In software development, getting the right level of abstraction is often a challenge. In semantically modeling a space, it's sort of the same thing, right? So we set about building it, and the result is summarized on the top left of this slide. And that's we call that the defend matrix. It's a tabular view. You can think of it as a countermeasure technique taxonomy. So that's a hierarchical, a hierarchy based on types, right? Of specific countermeasure functions that are being performed by many technologies, some IT technologies, some cybersecurity specific technologies, again, that might be bolted on after the fact. So we've broken it down in sort of a functional point of view. You'll notice across the top, we've got these things that we call defensive tactics. We're using that in sort of the sense of maneuver, which is a little bit of a military term. And then below that is this sort of technique hierarchy, right? And you can get as specific as you want to get with the model. So perhaps, of interest to this group in terms of data science and organizing information, we call this a knowledge graph. And you may be familiar with things like graph databases. There's different types of graph databases. There's property graph databases, and then there's another general type called semantic graph databases. And these semantic style databases let you encode a data model into the database directly, and that gives you sort of a lot of benefits. And defend fits into that second category here. It's called a knowledge graph, and a knowledge graph is sort of a type of knowledge base, where a knowledge base might just be, sort of plainly written articles about interesting, concepts. A knowledge graph is sort of the same thing, but there's actually a technical structure underneath of it that connects all these things together in a machine readable way, right? So that's why we call it a knowledge graph. I'm going to talk more about that and that model or structure and how that's built sort of into this graph. To talk a little bit more about the content in the graph and how we sort of came up with these definitions and these taxonomies. We actually have a variety of taxonomies inside of the graph, which I'll talk about. We started to, the corollary here was attack was built with a variety of data sources, but one of the most prominent being open source threat intelligence reporting, which is where if you go through the attack knowledge base, you click on the techniques in the articles, you'll see all the references to open source threat intelligence reports that vendors produce, right? So we had a sort of challenge. What would be a similar corpus for defensive technology if you're trying to describe defensive technologies? And we had the idea to go and take a look at all the patents that had been filed that were related to cybersecurity and kind of break them apart and try to take, say, a 20-page or 50-page patent. How do you reduce that into 2 or 3 words to describe it, right? So I'll talk about the methodology we used to do that, but it seems simple in hindsight, but as we were figuring it out, it was rather difficult, or it took us some time, let's put it that way. So we came up with these, and then since we had this corpus, yes, public corpus, these patents and various other things, that's sort of one type of document that we analyzed to build this. But we also looked at open specifications and also source code in some cases. We point to source code that vendors are starting to put onto GitHub, and we can characterize what that code is doing with our methodology for naming these things. And then we can sort of link to it, right? So that's sort of the source data for building defend. Then what we did was, well, once you build defend, you obviously want to relate it to offense, and what of these defensive functions cover these particular offensive techniques, right? So so what we did was, naturally we sort of did what happens a lot in cybersecurity spaces, where you start this sort of mapping exercise where you say, well, this thing is, covers or addresses this other thing because some free form description of why, or some sort of justification. And we felt like that would not be a manageable approach because of the scale of these models we're dealing with. So we came up with this approach where you'll notice in the middle here, we're mapping these defensive techniques to these offensive techniques, but we're going through an intermediate model, right? And that's sort of the key innovation of our R&D, I think, was figuring that out. So we ended up needing to build this intermediate model, which basically describes how computers work, like at a simple level, like a CS 101 sort of level, where we take all these computing concepts, and then we just define them, and then we define their relationships to other things. And then that lets us sort of reason about, well, this one defensive technique might be related to this offensive technique because they're interacting with this same concept that we call a digital artifact, right? So you could imagine an offensive technique producing digital artifacts, and then you can imagine a defensive technique observing them over time, right? And then I can then make an inferred relationship. Okay, this one defensive technique might address this one offensive technique because they're interacting with the same things in the computer, right? So take sort of a mental image of this, simplified graphic here. On the next slide, I'm going to break it down with specific examples so you can see what I'm talking about. So this is the same sort of view, but blown up with specific examples. So on the left, you've got the offensive model, in this case, attack. And then on the right, you've got a defensive model, defend. And then in the middle is this model of what we call digital artifacts. We call it a digital artifact ontology. And for folks who aren't familiar with ontologies, I describe it sort of this way. You can picture sort of, if your goal is to organize information, you can think of 3 levels of sophistication. Say first, a simple vocabulary where you've got a list of terms and definitions. Second might be a taxonomy, a hierarchy of types, and then associated definitions. So a dog is a type of mammal, which is a type of animal, for example, right? So that's a hierarchical improvement over the list, right? So then picture the third category of organizing information, which is imagine multiple taxonomies, but then more interestingly, the relationships between all of them. And then that creates this sort of graph structure. That's precisely what an ontology is. In this simplified example in the middle, you see yellow lines and blue lines. The yellow lines indicate type relationships, and then the blue lines indicate object property relationships. So that's sort of concept to concept relationships. So for example, in this case, an executable binary file contains code segments. And now you'll see we also have a more specific type of code segment here. We call it a process code segment. So this is a case where, as we were going through sort of standard computer science literature, in order to describe things specifically enough for cybersecurity use cases, we had to, in some cases, add on to standard terminology. So a code segment is often called a text segment. It's a portion of an executable file that contains the instructions for the program to run. But when the process on a computer is launched, a copy of that is sort of taken from the file on disk and put into memory. Well, if your process is being exploited by some sort of attack, say a process injection, they might be modifying the copy in memory and not the copy of the code segment on disk, right? So if you want to verify that those code segments are what you expect, you would take a different approach if you wanted to verify the integrity of the file on disk versus verify the integrity of the contents of the file that has been copied into memory. In this case, it's dealing with the memory example, and the defensive technique is this concept called process code segment verification. And then in this little picture here, you see 8 public references to documents that we found that look like they were doing that, right? So we built this model in the middle, and then we mapped the offensive and defensive sides to it independently. And there's a number of benefits in that approach. One, it's more scalable, but I think the better benefit is that you can explain why you think one defensive function will cover a particular offensive technique, and then you can have a discussion. Do you agree with this our assertions about reality? And then it's sort of explainable mappings, if you will. So once you map in either side, then you can use inference over this graph sort of structure to make additional relationships which were not explicitly defined. And this is in this space, they talk about reasoning and inference. This lets us make more complex sort of statements, or we get to analyze relationships in a more complex way than just simple mappings of one thing to another. I might be able to take into account type hierarchies. I might be able to take into account transitive relationships. So for example, if I'm verifying the whole of something, does that mean I'm also verifying all of its parts, right? And sort of these relationships you can define in that way. So one example of this is we might infer that because process code segment verification is verifying process code segments, and that process injection and these other offensive techniques are modifying them, we might infer, okay, this defensive technique might detect these particular offensive techniques, right? But we never had to explicitly say that. That's sort of the benefit of this inference-based approach. And then from a modeling perspective, you can take our sort of generic model, and then you could potentially, create a model of your own system, and then use our inference to sort of, identify particular countermeasures or threats to the individual components and pieces and parts in your system. So that's sort of the benefit of this sort of model-driven approach, right? So I'm going to switch over to a quick little demo to show you what that looks like in the user interface. So this website you can go to, it's defend@miter.org. It's free. And I'll orient you to the way that this view is laid out. This is obviously just showing a part of the model, and it's meant to give someone a starting point about where to look. But the key takeaway is defense, not just the table that you see here. There's a graph model behind it that you can actually use and customize for yourself. So across the top, you've got the tactics, like I said, and if you click on those, you get definitions. The example I went through before was a type of process analysis, which was process code segment verification. So if I click that, you get a knowledge base article where we made 3 sections: definition, how it works, and consideration section. And the definition is kind of the hardest part to write, because you're really trying to get succinct, because you want to be able to ask somebody, are you doing this, yes or no? And if they can't answer yes or no, then we need to maybe make the definition crisper. The how it works section is developed by looking at the references, which are at the bottom of this page. In this case, it's talking about verification logic. So when is the verification done? Is it done at runtime? Is it done during operations? Is it done at startup, for example? And where's the source of truth? So since it's talking about verification, that implies that there's a source of truth, which is slightly different, semantically than, say, something like validation. You might have a local source of truth that could be vulnerable to tampering. You might have a remote source of truth, which is harder to get at, to modify, right? Things like that matter to architects, right? The consideration section. So this is, I like to say this is the what do you wish you knew before you bought the product section. In this case, it's talking about false positives, false negatives. And then down here is where you start to see some of the graph and the inferred relationships. So this is in graph speak, this is a simple triple, right? Process code segment verification verifies process code segment. And then with that information, we can infer, okay, what are the related attack techniques? And these are potentially related. So it's not saying this is going to cover it every time. It's saying that these might be relevant. You know, and I will say, you'll notice it does say this is sort of experimental with this blue info box there. And what we're trying to do with this is to accelerate knowledge discovery. So that means that, you know, what it guesses might be relevant to you is not going to be perfect every time. But we are trying to put some things in front of you that you might not have thought about before. You know, complex relationships. So we intend to have a little wider aperture than just perfect mappings, if you will. So in this case, if it's not sort of obvious, this is a portion of the attack table, right? So looks like there's, you know, probably a handful of these various attack techniques grouped under the attack tactics. Just in case anybody's not familiar and you want to learn more about attack, you can go to attack.miter.org, and then you can see the full attack matrix here with all the different techniques and the tactics across the top there. But what we're doing is we're carving out the part of that that might be relevant for this particular defensive technique, right? And because we're using semantic relationships, we're able to be precise on the relationship itself. So I'll take a couple of these that came in through the inference and show you. If you hover over it, it says process hollowing modifies process code segments, right? And we talked about that. Well, then you'll see credential API hooking may modify process code segments. So, and that's because if you read the write-up on what this, you know, offensive technique is, sometimes they hook the APIs to dump the credentials through native operating system hooks, and they don't, like debug hooks, and they don't need to do any exploitation. Sometimes they do that through exploitation to put their own hooks in there. So so we put maybe, right? And you'll see that throughout the knowledge base. A lot of cybersecurity is dealing with the maybes and the, I might be able to do this, I might be able to do that, knowing how things work. So even though we're dealing with maybes, we've sort of systematically captured a lot of the maybes, if you will. And then down here, you see sort of the references we use to do this write-up. You can click on them. Most of these, in this case, are patents. One thing I'll point out, though, is we use a lot of references. Not all of them are patents. So that's sort of a common source of confusion, is we only care about patents. we only care about patents insofar as it lets us build our taxonomy and define the language. And then, you know, the goal of it is to just build the language model. But so you can see what some of those look like if you click on these. And some of them get pretty detailed about how they are implemented, but these are the sort of documents we read to build the knowledge base. So I'll give you two examples of how vendors have implemented this particular function in two radically different ways. One way, there was a third-party daemon which ran and checked all of the running processes, memory space, and compared what it saw there to what was in the binary files that they originated from. And if there was a difference, they assumed they might be tampered with. Another approach, which was radically different, inserted checksum logic into the executable files themselves with a custom compiler. And then as the process executed, it checked its own memory space and then sent the checksums to a third-party server for verification. So if you're a cybersecurity architect, you might, maybe you don't have the source code to your app, so you take the generic third-party daemon approach, but the checking is maybe more simplistic. If you do have the source code, you might compile it with this. If it's, let's say, the most important app you have, and it's you're most worried about it, and you can get a little more sophisticated, verification logic that's harder to tamper with, right? So that's a flavor of the type of information we're hoping to capture. It is an early stage project, but we do feel like our system for capturing this information is going to help us, grow it and get it to where it needs to be. So I'll switch back to my slides here. So I went through a demo. Sure, do a little time check here. Okay. So now I'm going to go over how we name these things. After this, I'll give you a simple use case of the first time we applied D3FEND after we had built it, and some of the insights we got there, and then I'll close out the presentation and open it up for questions. So the way we name these things is very simple, and there's 2 dimensions, and you could think of them as a noun and a verb. And I like to say, what are you doing to what, right? The verb in this example is analysis, and a more specific type of analysis is verification. And the verb is this notion of a defensive action and specificity. So we're saying you can get more specific, right? Semantically. And then the digital artifact is the noun, and that is also on this sort of spectrum where you can get more specific. In this case, a code segment, a code segment, then a process code segment. So it's really that simple. It did take us a while to figure that out, maybe embarrassingly, but once we got it down, we started to be able to more quickly articulate what something was doing. I will, since we've released it, I will say that some of the feedback we've gotten from folks is, we we think we know what these things do, but the more we dig into it, the more questions we have, right? And they found that this approach has been pretty useful in helping, enumerate the specific functionality of the products they have deployed. So one example of that was, this was sort of a analysis we did where we had a specific threat that we were concerned about. And then they wanted to know, do these 3 particular products address the threat, right? This particular threat is, you can visit the link there. But basically what it was doing was, somehow they got a malicious configuration file checked into a Git repository. And then everybody's IDE downloaded a jar file that was referenced in this configuration file, and then that developer was compromised. And then as they, as other people started to check out the code, it sort of spread that way, which was awfully clever. So that threat report was written and described, a variety of attack techniques, which we've put onto this summarized attack matrix on the left here. So initial access was a supply chain compromise. They were using boot or logon auto start execution for persistence. And then they were doing some defense evasion as well. So we took a similar approach in breaking down what are the functions that these cybersecurity products were performing and mapped them onto D3FEND like this. So you get a sense of, okay, they're doing some hardening techniques, they're doing some detection and a little bit of isolation, right? And then we stepped through the attack and wanted to know at what stage would the defensive have might have caught it or potentially dealt with it. So could they have done anything about the first stage? Well, yes, but these three specific products wouldn't have done much for it. Application hardening and platform hardening might have helped, but they didn't have that, right? Then we step through, and this was might have been caught by file analysis, which they had some of those capabilities, so we marked that as amber. And then this final one, or this second to last one here, installed a scheduled job, and that might have been dealt with if they were doing scheduled job analysis underneath of operating system monitoring, and then sort of so on and so forth. So one of the key takeaways for us initially was, okay, well, we're getting these higher level insights, which is sort of, well, if I was doing more application hardening, platform hardening, and operating system monitoring, and these are the higher level abstractions, we might have been able to address this. So I can think, sort of strategically at a higher level than just change this configuration over here, right? I need to better harden my platform. I need to better harden my applications, right? And then the other insight we had was getting a sense of the diversity of your defenses. So, and that's really hard to do if you don't group and categorize what these things are doing functionally. So consider two scenarios. One, you have a customer who is, or an environment where they are constrained in budget, and they need to maybe reduce duplication of effort, right? And maybe they have no coverage in one area, but some in another. Maybe they should, potentially, reallocate investment time, people's time into other areas to get a little broader coverage, right? Another scenario where, let's say you are in a situation where there is, more funds, and it's absolutely critical that they have very deep defenses. Now you know where you can potentially double up and say, well, I had some file analysis, but I want more of it. I want more diverse analytics. How many unique analytics do I have? How effective are they? What's their accuracy? What's their expected accuracy? How have they performed before? Those sorts of things. Having the categorization and organization lets you sort of do those comparisons and plot a story out on the board and communicate it. So that was sort of received pretty well. So here I'll leave you with some final thoughts. One thing we're seeing is folks starting to use D3FEND in the wild. We're seeing some vendors start to map what their technologies do to specific D3FEND techniques, which is exactly why we designed and built the framework. We're getting a lot of feedback from folks and contributions about things we're missing, things we have to add, and we're very actively engaging on that. So what are some things you can do? You can ask your vendors what D3FEND techniques do they support, right? Thinking in terms of digital artifacts and defensive verbs, because really what we want to be able to do is say, with this specific function or D3FEND technique, we are able to detect these specific attack techniques, or these specific, very specific technical techniques by the adversary, right? So then I can map all my functions and understand where I'm getting, good return on investment. You can, of course, browse the website at defend.miter.org. And if you want to go and play with the ontology, there's open source tools you can use to open it up and edit it and add your own things. Protege is a very popular one, and it should load right up in there if you download it. And then finally, you can contact us at defend@miter.org with any questions, feedback. We're pretty collaborative, so don't hesitate. Right. So that's all I've got. Thank you very much for inviting me, and it was great to get to talk to you.
Hey, Peter, there was actually a couple questions. The first question was, Are there any public RDF data sets that implement the attack or defend models, or data sets that have these models can link to? I think I worded that right. Is there any public RDF data sets that basically are using these, I believe?
Um, so defend is encoded in RDF, and defend has some of a small portion of attack inside of the ontology file, because that's how we relate to it. So in a sense, defend is a public RDF data set that you can use. I'm not aware of another one that is using it at the moment, though there are some other research organizations that are planning to release things that do integrate with defend, but that's I haven't seen those yet. So that's the best answer I have there. And if you want to get more specific too, I can dig in.
There was also a question similar about, well, actually, there's a different question. Were all the concepts that were captured in the graph known to have been in the real world? Like, was there anything, and I guess I want to add to that, is there anything that's in there that's like theoretical that hasn't been done?
So most of what and that's another good point. Something I didn't mention was that defend was built from the bottom up. So versus the sort of top down, right? Where you say, what are all the things we could do in all the possible, and then eventually when you get to the leaves, there's there's not that much detail. We took the opposite approach. So we started at the leaves, and the tree emerged after the fact. Most of the things we felt do exist, but that's not to say that they work well necessarily, because whether or not something works well is highly dependent on your environment. What works for an internet service providers might not work for a 10 computer network very well, or vice versa. So in general, though, most of them do exist.
So are you guys actively like updating attack and defend?
Yes, and that's another point I want to make is attack and defend are two they're two separately funded projects, and they both do get constant updates. So attack has, I think, 2 updates a year, and then defend is very early stage. So we'll probably do more releases in the early phases, but eventually we kind of want to get in sync with when attack does releases. We're going to be doing another release before the end of the year, and it's going to have some pretty good updates, and we've got some exciting stuff planned that we're looking forward to releasing as well.
So do you guys, there was a question about, have you ever thought about, or do you do any linking to open data sources? And he gave an example of DBpedia, which he said is a knowledge graph version of Wikipedia, and potentially like linking up your stuff
Yes.
to them. And I did see like you had all that patent stuff, so I was assuming you are doing some linking.
Yes. So I'll actually, I think my screen share is still coming through.
Yes.
So I only showed kind of the tip of the iceberg here. So there's a couple things. One is I didn't show this view here, but if you search for an attack technique in defend, you'll get sort of the graph, all of what defend knows about it, basically. So here you see the offensive technique, and then you see defensive techniques on the left, and then you see these digital artifacts, right, in yellow, and you see the rootkit might be modifying them. Well, these digital artifact definitions that we have about 500 of these, and if you click on them, like a kernel module, for example, in fact, you'll see we link to, in this case, we're linking to Wikipedia. Usually we link to DBpedia, so that's kind of a bit of a surprise. But if you click on the artifacts page, you'll see all the definitions we have for these digital artifacts. 3 major categories: files, network traffic, software. There's lots of different files out there, and you care about them in different ways in terms of their security properties. So you see sort of an entire taxonomy here of all the different file types, all the related countermeasure techniques to a particular file type, and then all the related offensive techniques to a particular file type. And you can see, there's a lot going on there, but you can kind of narrow in on the tree. Okay, what about, I just care about document files, right? And you get a much smaller section. Then you'll notice we link to DBpedia. So this is kind of like, the technologies here fall under the umbrella of the semantic web, and recognizing that some folks, not to go down a rabbit hole there. But yes, so we do link to those. You noticed maybe on this last one, in this case, it's linking to Princeton WordNet, right? So WordNet is a huge project that deals with synonyms and so on and so forth. So we do actually use those sorts of things, right?
So there was a couple questions related about kind of like the more technical implementation of are using graph databases, like what is some of the tech behind, I guess, the website?
Yeah. So, well, if you dig into the website, you can figure out some of the front end tech we're using. It's a JavaScript Svelte app, and specifically the Sapper framework. And then the database, we're using a graph database, which it's just free, and you can load D3FEND into it, right? And query it. There's lots of graph databases that support these data formats. So if you go onto the resources page and you download the file, so I recommend using the RDF OWL file. You can load this into things like BlazeGraph or Virtuoso, or there's a lot of other, I think, Stardog. There's a lot of these, but that's sort of why we're using these standard semantic technologies, right? And then the way that we produce the website is we compute all the possible queries against the graph, and that produces a whole lot of static HTML, JavaScript, CSS, and JSON files. And then I don't have to run an active web server because we're a small team. So
There was a question, it's a little longer, so hold on. It's basically larger security organizations tend to silo these countermeasures across individual teams. In a perfect world, how would you suggest a large organization effectively adopt this framework, whether a large government agency or a Fortune 100 company?
That's a good question. And one of the target audiences we focused on was this notion of a cybersecurity architect. And I do think there's a lot of siloing, but I also do see some very large organizations that have folks who are in charge of the architecture at the highest level. And they might be useful in kind of accepting inputs from everybody else and then having a summarized view in one sort of pane. But you might have multiple views, right? So if you're trying to use this for your organization, you might need to fill out, like if you were going to, so it depends on how sophisticated you want to get with your modeling, right? A simple method might be, well, if you were just coloring the squares on the matrix, right, you might have a variety of different copies of this filled out by different teams. If you wanted to get more sophisticated, you might actually take the model itself and create instances of the classes in the model and then add more properties to them, like which team owns it. But then you could get sort of a comprehensive view of that. And we actually have seen very large organizations doing that. And in fact, we're kind of blown away at some of the stuff that folks have contacted us with and said, here's how we're using it. And they're really going to town. But that requires taking this file here and then learning some of these technologies and building your own local instance of a knowledge graph, if you will, right?
I was actually wondering, are you able to share any more about some of the other use cases, like how people are using it?
We will hopefully soon. Some of that's not my information to share, but I will be asking them to do that. And I hope to make that, one thing we're thinking about is what sort of public forum could we develop to have folks come together, sort of like a community of practice around this, and talk about how you're using it. To wonk out a little bit on the modeling, we designed the model to not, so we could have designed the model in such a way that would have made it not extensible. But we went through great sort of great pains to make it extensible, and that meant we had to do some a little wonky things in the ontology itself. And I guess I don't want to go too far down that rabbit hole, but basically, it's designed to be extended, right? And I think getting some sort of community of practice around that is a high priority for us.
Have you seen any like any blog posts or any open source people reference it and do anything like side projects that's not, like corporations or government?
Not corporations or government. We've seen a little bit of activity on GitHub, not a ton, I would say. We have seen a lot of, what's interesting is folks, we've seen a lot of folks in other countries actually really pick it up, and they've contacted us, and some folks have developed training courses around it because it's kind of like a good intro to cyber defense. Like it's almost like a good table of contents, right? We saw one person, one group had developed a multi-day training course around it, and it was cool to see. I think that one of the things that we'll have to do to get more sort of projects using it is to open source some of the tooling we use to build it, and that is a priority for us in the midterm, I'd say, and to quickly spin somebody up on the pipeline used to manage the knowledge graph. There's a few rough edges we want to work out before we do that. But I will say that, before I had started this project, I hadn't used any of these graph technologies before. And in particular, so the queries, I will say, are written in a language called Sparkle. And it's a graph query language that I totally underappreciated before I started this project. And once I realized the power of it, I was like sort of blown away. And it can be a lot of fun to work with this sort of stuff, I think.
There was a question actually on YouTube that I missed. Do you have any idea how big the graph is?
Yes, it's around 16,000 triples, give or take.
Okay, thanks.
That's a number we sort of monitor. So
there really was any other questions. There was some interest to see if your slides would be available. That's something you can let me know afterwards. Mm-hmm. But other than that, is there any other questions? Last call. Okay. All right. I don't see anything. That was very interesting, Peter. It seems like a lot of work. Actually, that would be my last question for you. Like overall, how long did this take, from start to the current state? It seems like it's a lot of information, a lot of data.
Yeah. We worked on it for about 3 years, but again, we were a small team. I was working about half time on it, right? And I had partial time of other folks. Again, it was a very small team, so level set expectations, right? and that's where, being in a research and development environment, we had a very good research and development environment where they let us have the time needed to figure out some of the weedy sides of the problem. It took, I would say it took us probably a year and a quarter before we were like, aha, this is how we're going to do it. And, we could have done it very simply and just made a list of all the interesting cyber countermeasures and just been done with it. But we really wanted to build that model, and that's what took a while. So.
Do you know how that relates to attack? Did that take just as longer, or?
Oh yeah. So attack, I don't want to be quoted on the age of the project, but I think it's over 5 years, maybe 7 years. And so for perspective, and it's been a big, a lot of work to get that to where it is, and the team does a fantastic job updating that information. It's very. I have a whole new after going down this sort of rabbit hole. I have a whole new appreciation for what it takes to put out content like that. It's definitely a lot of work. Developing the data model in particular, it's easy. So I think data modeling has to kind of be a team sport, and it's very tempting to just go off, oh, I could just figure it out, right? But if you're trying to get agreement on language, you have to have these extended conversations about the most like specific technical details, like for 30 minutes, an hour. And it takes a lot of patience for everyone involved to come to agreement. And so it's been a lot of fun with the team for sure.
Very cool. Well, thank you so much, Peter, for joining us and talking. That was really awesome. And I think there were, some good questions. And thanks everyone for attending. Hope to see you guys at a future meetup. It's probably not going to be until 22, but thank you very much, Peter. If you ever need anything, just let me know. And have a good evening, everyone.